Hey GED students, it's GED question of the day time, and it looks like I'm looking at another greatest common factor problem here. We see what is the greatest common factor of 27, 45, and 81. So I'll remind you that greatest common factor problems, this is a basic skill which works its way into many different math concepts. But in addition to that, you might just see a GCF problem on your first 5 problems, the GED, the ones where you don't get any calculator. So this in and of itself is a GED problem. And it also will help you do things like fractions and factoring. Okay, so what is the greatest common factor of 27, 45, and 81? I'm going to use my little trick GCF method just because I don't feel like making a factor rainbow of all these numbers. It would take me a long time and I'm lazy. I'm going to do the trick where you remove one factor at a time until the 3 numbers, in this case 3 numbers, have no factors left in common. So I happen to know that 27, 45, and 81 are all divisible by 3. And if you're wondering how I know that, I used a sum of digits trick. Sum of digits trick tells me that if you add the digits, individual digits in the numbers together and you get something divisible by 3, then the number itself is divisible by 3. For example, if I added together the individual digits in 27, 2 plus 7, I'd get 9. 9 is on the 3 times tables, and so is 27. Same thing with 45. 4 plus 5 would give me 9. Again, I'm on the 3 times tables. Same thing with 8 plus 1. So even if you don't know your high times tables, you ought to be able to at least pull a 3 out of each of these numbers. Now, let's do that division. So 3 goes into 27 9 times. That's a multiplication fact I have memorized. 3 goes into 45. I can use sight division for that. 3 goes into 4 once. The remainder 1. 3 goes into 15 5 times. And if you don't know sight division or short division, I suggest you Google it. It's a beautiful skill. 3 goes into 8 twice, remainder 2, and 3 goes into 21 7 times. And now I can see once again that I have 3 numbers remaining. And what I notice of these 3 numbers is that they still have a 3 in common. They still do. 9 is on the 3 times tables, 15 is on the 3 times tables, 27 is on the 3 times tables. I'm going to pull out the remaining 3 they have in common. And now let's see what we have left. 9 divided by 3 is 3. 15 divided by 3 is 5. 27 divided by 3 is 9. Now my numbers are a little smaller. And so now they'll be easier, as every time you divide out, it'll get easier and easier to look at your numbers. 3, 5, and 9, the greatest common factor of those, the biggest thing they have in common is just 1, obviously. They're the only factors that divide 3 are 1 and 3, and I'm not going to be able to divide 5 by 3. So I'm not going to find something that they all have in common besides 1. And so I always joke 1 and done with my class. As soon as you get to a line where 1 is the only thing they have in common, you're done. And so really my only important factors here are 3's, 2 of them. So I pulled them out through division. I'll put them back together through multiplication. The greatest common factor of 27, 45, and 81 is 3 times 3, or 9. And if I were writing it like a mathematician, I would write the greatest common factor of 27, 45, and 81 is 3. But, is 3. Oh my goodness, you guys. It's a good thing I'm paying attention, is 9. But no matter which way you write it, whether you write it like a mathematician or you just tell me the answer is 9, I get what you mean. So answer here is 9. If you have any questions about this or any other math topic, be sure to drop them in the comments and I'll do my best to answer them.